2x plus 1 dx. Okay. All right. So, Erin, you looked at this problem. What were your thoughts?
Well, I thought use substitution first, which didn't go anywhere.
Okay.
And then I figured the only other option then is to do the integration by parts, but just the natural log of 2x plus 1 times dx. And then I started to get lost after that.
All right. So, Becky, did you have similar thoughts on this?
Yeah, use u as natural log of 2x plus 1.
Okay, so let's try that out. So that makes sense. In terms of looking at this problem as integration by parts, our acronym starts with an L, which is log, and so a really good choice for the U will be the natural log. Now, you can't just write down ln, I mean it's ln of something, so it's ln of 2x plus 1. And that means that all that's left over is just the dx, so our dv is equal to dx. Okay, now based on our rules of thumb for our integration by parts, we've set this up correctly. We've used our log as our u, and then whatever's left over as our dv. Okay, so now I look at this and I take an antiderivative and I say, okay, well, let me take that back. Let me start that whole sentence over again there. Okay. I've got a u, and I want to find its derivative. So I look at the derivative of natural log, and I have to use the chain rule. I have 1 over 2x plus 1 times the derivative of the inside, which is 2. And when I take my antiderivative, I end up with v is equal to x. Okay. So now I go back over here to my integral, and I've got the integral, I've got uv minus the integral of v du. And so my u is natural log of 2x plus 1. My v is x, so times x, minus the integral of v, which is x, times du, which is 1 over 2x plus 1 times 2 dx. Okay, so my beginning stuff, my u and my v are totally legit. And this integral over here, I absolutely positively need to clean this up before I keep going. So some things that I can do once I write down, and I'm going to put this x at the beginning. I'm going to get x times the natural log of 2x plus 1 minus, I'll pull the 2 into the front, the integral of x over 2x plus 1 dx. Okay, any questions about that? Okay, so what are we going to do about this x over 2x plus 1? Any, Becky or Erin, any thoughts? Okay, so what would you like your u sub to be?
2x plus 1.
Okay, so this seems like maybe a reasonable option. Maybe we can look at this and say, okay, let's do a u substitution on this. And so our u sub will be u is equal to 2x plus 1. And I work through the derivatives. Du over dx is equal to 2, so dx is equal to du over 2. And so now I can copy down all this stuff at the beginning, and I just carry it along. I don't do anything else with it. Minus 2 times the integral of x over u, and my dx is du over 2. Okay. And I'm a little sad because I see an x up here, but at least I can cancel these 2's. One's on the top, one's on the bottom. All right, what about that extra x?
I solved u equals 2x plus 1 would be x equals.
So we've got x is equal to u minus 1 over 2, which we could also write as x is equal to 1/2 u minus 1/2. Okay, So this seems like this could be something that we could work with here. Okay, so we've got x times the natural log of 2x plus 1 minus the integral of 1/2 u minus 1/2 over u du. Okay, now this is actually nicer than what we had to start with, the integral of x over 2x plus 1. The reason that this expression is nicer is because this one up here we can simplify, because all we have in the denominator is a u. And so this one we can simplify, whereas algebraically we could not simplify this one over here, because we had a plus in the denominator. Okay, so we'll write this down. X times natural log of 2x plus 1 minus the integral of 1/2 minus 1/2 times 1 over u du. Alright, so when I look at these pieces, the reason I wrote this as 1/2 times 1 over u is that way I don't have 1 over 2u that I have to do another u substitution. So if I think of this as 1/2 times 1 over u, I can do the antiderivative of 1 over u.
Where did your u go on the bottom of it?
This one here?
Yeah.
So the step that I've skipped here is I'm dividing the u into both terms.
Oh, okay.
And so this first one may cancel, and then this one becomes 1/2 times 1
Yeah,
over
you
u.
just do that.
Okay, other questions about this integral right here? Alright, so in that case, this beginning stuff, again, I can put quote marks if I want to. Minus, now it's minus everything else that I do. So I need to have brackets. Antiderivative, yes, Andrew?
Where's the u on the top? In the where'd that go?
So when I divided
okay.
the u into both terms,
Yeah, right.
and in the first one they cancel.
Right.
Good questions. Okay, other questions? Okay, so now I've got 1/2. I take its antiderivative, and I have 1/2 u, remembering that we are talking about the variable u. So 1/2 u minus 1/2 times the natural log of the absolute value of u. Alright, so at this point I can do a little dance. I mean, I have no more integral signs. I'm very happy about that. But I'm not quite done with the problem. I have to flip my u's back into the x's. Now, just as a point of bookkeeping, be a little bit cognizant and a little bit aware that you have u's all over the place here. We've got the u from the integration by parts, and we also have the u from the u sub. And so when you go back, I mean, it's been a while since we started this problem, so when you go back, make sure that you make the substitution correctly. That this u we're changing back is the u from the u substitution. Got it?
Could you have factored out the 1/2 on the top step there?
Yeah, that actually would have been a really good idea. We could have pulled out the 1/2, and then it would be 1 minus 1 over u. Absolutely, yep. Good idea. Okay. So here we go. We've got x times the natural log of 2x plus 1, exactly copied down, minus, and then I've got brackets 1/2 times 2x plus 1, minus 1/2 times the natural log of the absolute value of 2x plus 1, end bracket plus 3. All right. So the moral of this story is that 80% of the time when you're working on these problems, even if you start out and say, I'm going to use integration by parts, then built into that integration by parts could very well be some other kind of technique that's going on. And so integration by parts gets you started, and then you might have some kind of a u sub down here or something tricky that goes along with it.
So you couldn't do u sub from right from the beginning?
So if you wanted to, you could have set this up in the beginning as...
Because I was on, the answer that you got right there is like totally different from what the book has. So I
if you start out in the beginning and you start out with natural log of 2x plus 1 dx and say, let's let u, and do a u sub first, because we have something fancy inside the parentheses, we would say u is equal to 2x plus 1. And
du
so,
is du over 2 equals dx.
yeah, so dx is equal to du over 2 once you do that work there. And so we have the integral of 1/2 natural log of u du. And now we'd have to say, okay, how am I going to deal with this? And here you would say, okay, I'm still going to have to use integration by parts. And so now we've got something where I say, I'm a little bummed because I've already used a u and now I want to let u be something else. So I might go back here and say, well, let's make this a w sub. And fix that problem so we don't have u's all over the place. And then I can still do my integration by parts. So my u is natural log of w, my dv is dw, and I can work my integration by parts this way as well.
So that's valid?
Yeah, absolutely.
I did it that way then, so that's
Yep. And so, yeah, so absolutely you can keep going like this. It makes your life a little bit easier in terms of your derivative. And in fact, when you do this, we've got 1/2 times, okay, uv, natural log of w, times w minus the integral of v
times w.
times du, which is 1 over w dw.
It's that equals just 1.
Yeah, this is nice. This cancels. So we've got 1/2 natural log of w times w minus the integral of 1 dw.
Which that just turns into w.
So this guy is easy. We have 1/2 natural log of w times w minus w and a plus c at the end.
Nice. So you can do it that way?
Absolutely.
Killer.
And so if we go about it this way, we're still not done.
You gotta plug in your u.
Turn back into our x's.
W.
And so we end up with 1/2 times the natural log of w, which was natural log of 2x plus 1, times w, which is 2x plus 1, minus w, which is 2x plus 1. And then plus c at the end.
Nice.
And so, also a valid final answer. And so then the question becomes, are these really the same? And I would encourage you to maybe try and simplify one or the other and try and make them look similar to each other and see if they come up to be the same. Okay?
If you put those equal to each other, could you find out what x is?
Well, what should happen, the answer to that is no. What you should find out is that if you were to set them equal to each other, everything should eventually either cancel out, and you'd be left with 0 equals 0, or you'd be left with one constant number equals another constant number, which isn't technically true because these two expressions may or not be exactly equal to each other. They could differ by a constant. So you really want to avoid setting them equal to each other because of that reason. Okay. All right, so on this particular problem, should we start with integration by parts or should we start with a u substitution? Well, the first time you do the problem, it's not clear at all what you should do first. And in fact, both ideas, you can approach it either integration by parts first or u substitution first.
Would it be like this, whatever way is easier for you, I guess?
In some cases like this one here, then yes, where you know, whatever floats your boat higher in the water is one you want to try first.
How difficult is the test going to be in relation to these problems? Is it about the same, or are we going to have to do like 6 iterations, or?
That's a good question. So what should you expect from an exam? Well, what I hope that by working on the practice problems, that prepares you well for the exam. Practice problems and homework assignments, turn assignments.